So U-substitution is one of the most common forms of integration, and the name tells you exactly what you need to do. So let's take a look at the integral of cosine of 3x dx. The very first thing you need to do is identify your u. So in this case, I'll identify u as 3x. And then you need a du, or the derivative of u. And the derivative of 3x is just 3. You need dx at the end. So now what I can do is isolate dx. So dx is going to be equal to du divided by 3. So now what I can do is substitute. So I take u and substitute that in for 3x. And I take what I find for dx and substitute that in for dx. So I get the integral of cosine of u times dx, which is equal to du over 3. Du over 3 can be written as 1/3 du, and 1/3 is a constant, so we can take that outside the integral. So now I can rewrite it as 1/3 times the integral of cosine of u du. And we know what the integral of cosine of u is. Well, it's sine of u because you derive sine to get to cosine. So 1/3 sine of u. The du automatically goes away when you integrate. And we know that u, as mentioned before, is already equal to 3x, so we can substitute that back in for u. So the final answer is 1/3 sine of 3x, and since this is an indefinite integral, we need plus c. So let's take a look at the integral of 2x e to the x squared dx. So very first step obviously is to choose your u, and you need to be able to choose a u that when you derive it, it will cancel out a term in the function. So in this case, I know I can choose my u as x squared, because when I derive x squared, or when I say du, I'll get 2x dx. And there's already a 2x in the function, so I can cancel that out. So I can say dx is equal to du divided by 2x to isolate the dx. And now I can plug my u and my dx into my equation. So we get the integral of 2x. We already said u is x squared, so we can put e to the u. And we know that dx is equal to du over 2x. So now when I simplify this, the 2x's will cancel, and we'll just have the integral of e to the u du. The derivative, or the integral of e to the u, is e to the u, because we derive e to the u to get to e to the u. So the integral is e to the u, du goes away, and we know that u is equal to x squared, as mentioned up there. So we get e to the x squared and plus c is our final answer. Now let's take a look at the integral of 5 over x times the square root of ln x dx. In this case, I would actually choose my u as ln x itself, because what will happen is I'll be able to cancel out the x's later on. So when I derive u, or when I derive ln x, the derivative of ln x is just 1 over x dx. And when I isolate dx, dx is going to be equal to x times du, since we're multiplying by the reciprocal. So now when I plug them back into the equation, I'm going to get the integral of 5 over x times the square root of u, since u is equal to ln x, multiplied by dx, which is equal to x du. As you can see, the x's will cancel. The 5 can come out front because it's a constant, and so we're left with 5 times the integral of 1 over the square root of u du. Now what I can do is change the u to its exponent form. So let's say we get 5 times the integral of 1 over u to the 1/2. And I can move that 1/2 up top and make the power negative. Now what I can do is use the power rule. So recall that the integral power rule is you add the power by 1 and divide by the same power. So we get 5 times negative 1/2 plus 1 is 1/2. And then we're going to divide by 1/2. But when we divide by 1/2, we multiply by 2. The du will go away when we integrate. 5 times 2 is 10 times u to the 1/2 power. And we already know that u is equal to ln x. So the final answer is 10 times ln x to the 1/2 power plus c.